Yeah, well, also one more thing to emphasize is that from last time, I think I missed one important, well, not that important, but basically, if you think about the way that you call the variables, right? So it's self. So basically, attributes is going to be self dot the attribute name. But then when you call the method, you just need to realize the method is written as a function in your class. So you do need to enclose the brackets. Okay, so it's like basically just the input is gonna be the default. The self is the name of your object that's carried through for the identification. Okay, so but yeah, you need to enclose the bracket there. So just one thing to mention. Another comment that I like to quickly also mention is that last time when I was coding this part, I got into a bug, and the bug is actually really common. If basically, so notice here at the on the top, I have a class. Basically, depending on your code, you can have a variance of a class. But then my recommendation here is that when you define your houses, you may want to put them in the same cell. So basically, the thing here is that when you are changing your class, uh, you would like to also update your house information so that the new attributes and the methods are also encoded in the memory. So that basically whenever you call, you will not get issues. So basically here, what I'm doing is that, okay, I have some methods that I commented out. Okay, so then basically if I run, the house will still encode, but then these methods are not callable, right? So now so what I do here is I simply just uncomment so that they will be correct in the class. However, if you don't run the repopulation of your house again, then those methods will still not be callable. So there's a problem here. Okay, so this is an inconsistency that you may want to get rid of when you are editing your class. So that's the recommendation here. Just so they need to be somehow simultaneously changed. Otherwise, you would be confused why the thing is bugged. Okay, so that's a common issue there. Okay, I do see that most of you guys are playing with the beginning parts of this lecture 7 live coding. So yeah, we can start with that. Um, First question is about reversing a string, which now we know indeed there's a way to efficiently do it. Uh, so if you want to do it in one line, right? So it's basically the slicing that you just reverse the order. Remember, this kind of method always gives you for a string, it will give you a new string. So just now when I was writing the uh, palindrome checking function, if I if I simply get rid of that reassignment of my parameter, then what does it do? So as is a string, firstly, I try to get rid of the spaces. But now that reproduce you another string. Okay, so that will be, so let's say the original you have an S, then there's going to be a T. And then here the lowercase is doing the thing to the original. Okay, so that's something you need to watch out for. So remember, for string operations, it will give you another output. So let's say if you want to keep the old data unchanged, you would say let's make a copy of S, and then I manipulate T, and I also rewrite T. Okay, so so here as you want to not change it. So T is what you want to manipulate and then replace the spaces, but then also replace T. And then similarly, on the new data, now you have no spaces and you lowercase all the letters, and then also just update T. And then finally, you want to check whether your now lowercase without space string is going to be um, a palindrome or not. So so basically, that was it a cat I saw that string over there. If you remove the spaces and get the things lowercase, then it's going to be symmetric or palindrome in a sense. Okay, so and you can also make sure that you play with some other strings so that it will not give you false positive, and neither will give you false negative. So so yeah, basically, if you do not, yeah, let me do that to show you. If you do not update your string, it will give you just not what you want, because it's gonna always give you a false. Of course, because you produce another string and a third string without checking, without making it the way that you want. Okay, so you need to update your string to go further. So yeah, so those methods are from lecture 5. But now you see, okay, indeed, you are in the object of strings, then replace lower, upper. So those are the methods that are in this class uh, of strings. Right? So yeah, so of course, make sure to go back to lecture 5 if you need to be reminded about the methods. Okay. Um, yeah, by the way, why I keep this as another copy? Because here we're returning true or false, right? But sometimes if you feel that true or false is not interpretable in terms of an answer, you may want to return like a sentence. And your sentence may include your original data. That's like basically you may want to say, okay, was it a cat I saw? This entire sentence is actually a palindrome. So if you want to return that, you have this option. Okay, so when your code is keeping a copy of the original data. So what I want to say here is return it is true. Okay, F string. So just that will make the things a little bit easier. So if I want to say it uh the string the string S is wait, let me think. So yeah, well, it's true or false, then I would want to say something at the beginning of the sentence. It is true or false that the string is palindrome. It is that the string S is okay. So let's try that. All right. And probably let me think. Wait. So the wrong place. It should be enclosing the string that I have. Okay. It looks better. So yeah, well, many times, especially when you are doing those experiments, okay, you would want your code to give you something that's readable. So that's probably a choice. Okay, that's also giving you the original data. And of course, if you feel that the true and false they have capital letters that do not read in a natural way, and giving some other giving others like an indication that these are Boolean variables, then you may want to hide it, right? So maybe you may want to convert it to a string and then put it in lowercase so that it reads a little bit more natural. So that's always doable. So what I can do. So basically, yeah, it's indeed building on top of original versions of your code. So it's let me make it lower. So that's gonna read a little bit more natural. So now the sentence looks in natural language. These are like tiny little tricks that you can play with. And this kind of treatment is especially the case when you later play with the class. Because later, let's say you have a house, right? You're checking whether the windows are closed, whether the doors are locked, right? And then you're gonna have a bunch of Boolean variables that you are returning. Then this true or false is representing what? So then you probably want to return a sentence instead of just a true or false to indicate what's going on. Right. What's the next one? Oh, least comprehension. Yeah, let's any questions about? Okay, good. So list comprehension, yeah, just one line. Yeah, well there are a few ways, but make sure to play with this one. So there's a lambda function, or is a one line of list comprehension that you can do also. So one comment for question two here is that so yeah, so make sure to play with with the list construction. But basically, if you think about what's going on with n squared minus two plus one, it's actually n minus one whole thing squared. So essentially, you're looking for so that's square divisible by three is actually saying n minus one is divisible by three. So essentially, you're looking for the three multiples plus one. Okay, so you are looking for all the numbers modulo three. That's giving you one as a remainder. So that's why we are looking at 1, 4, 7, 10, and 13. So essentially, those are the numbers you are kind of expecting. So this is indeed constructing a list. Okay, the elements are in the form of n, and you are running n from 0 through 16, well, excluding the right hand point for range, and then you want to verify that the number that you have is divisible by 3 or not. So if you don't include the brackets, then you will get something wrong. So So you do need the bracket to have it as the numerator, okay, for the division.
Wait, I don't completely understand what is this question asking.
Oh, so this is saying okay. Uh, the second one says store the corresponding numbers of the form this. So basically, you're looking for the outputs. So the previous part is looking for the inputs n. Now here you are looking for the outputs in another list. So here we are printing that, but in case you want the things in pairs, then you can do this. Oh, that's for C. Use the list comprehension to create a list of. Okay, that's okay. That's good. So yeah. Okay. Let me get that to C part. Just in case. Yeah, and I think we did question three earlier, right? So just one line. Uh, wait. Use it to make a list of the entries all possible sums of the. Let's Okay, I'm a little bit confused as why I have the division, but okay, it's probably a condition that I that I mentioned during the class, but we don't really need that part, but just like a variant of the code, so which is something you can do, of course, for conditionals. So yeah. Well, a lot of the times you don't really need conditionals when you are just manipulating the data, uh, and not screening out unwanted ones. But in case you do, then you may want to include the conditionals for that. So yeah, but this part should be straightforward. So yeah, well, you have x plus y for all x in A and y in B. And you can also have AI BJ for when you're running the indices. So that's something we have seen from before. Question four on derivatives. Oh, okay. Yeah, this question four is pretty interesting. So make sure to play with this. And of course, if you need hints, you can also, of course, discuss and also look up on the screen. So, if you need a hint for this question four, basically you just say, okay, my dx is gonna be an input, so I just swap the line to the input there. And essentially, what are you doing? So the k derivative is actually you have the k minus one's derivative, and then you differentiate once again, right? But earlier we are using the secant slope, so what you can do here is, okay, I use the k minus one derivative, which is a function. I evaluate at two points, x plus dx and x, and then I do the change of output over the change of input. So that's but of course you do realize this whole kind of division is actually done for our derivative approximation. So either way is fine. So on a high level, you can directly just call derivative function there. Uh, so it's sort of like a recursion there. Okay. And what you are doing here is, okay, I have x, the experiment here is x squared, right? X squared, if you think about the high level a third order derivative, it's going to give you a zero. So this secant line approximation definitely is not perfect. And it will give you something weird when your power gets higher and higher. What's the reason? The reason is because your dx is actually small. The higher power that is, the more inaccuracy there is for your computation. Okay, so later for the next part, when you're playing with the that approximation there, you will see something weird. That if your dx gets too small, then the error may be significant. That's because the power that's higher that will give you less than machine epsilon. So it will be rounded off as zero. So there will be weird issues going on there. Machine epsilon is like what? It's like 10 to the negative 16, which is easy to obtain when your power is large. So yeah, well, for question four, make sure to think about the way to systematically give outputs. Okay. So the thing here is that, okay, basically saying, okay, I have g of x equal to x to the 4. I'm having x equal to 10, and step size is delta dx 0.001, 0001. But then if we have larger, smaller this value, then you may need to choose a bunch of different choices like point 1, point 0.01, point 0.001, point 0.001, point 0.0000. So four zeros are one and five zeros are one. And then you may think about like a for loop, right? And then suppose you have point 0.0002, then that will give you another for loop. So you may want to think about systematic ways instead of just doing like a number of choices by hand. Okay, so that's something you want to experiment on. third derivative.
Exercise that we confidence accuracy.
That's a search. You do need to search. So here what I'm doing is I'm gonna choose the step size to be, let's say, 10 to negative I, okay, for I from 1 through 6. So, and then I may do other searches. So, 0.1. So that's something really critical in machine learning, that the learning rate is always something you need to search. Yeah, well, it's always make sure to have the colons. So yeah, if you look at the arrow, so I'm just x to the 4, right? The derivative is 4x cubed, then the second derivative is 12x squared, and then 24x, right? The third derivative. Here we are approximating the third derivative at 10, so it's going to be 240. That's the correct answer. So you have 3.5, 0.35, 0.033, but then now it's popping up. Okay, so it's going to be 1.9 and then negative 240. That's weird, right? Why is that? So if you think about this, you're subtracting by 240. So that tells you the third derivative approximation is like 10, it's like 0. So that's basically resulted from numerical errors. That's our power is negative 10 to negative 4. Okay, so that's lambda equal to 10 to negative 4. But now when it's 10 to negative 5, 10 to negative 5. Then the last one is 10 to negative 6. Now the error gets huge. Okay, so indeed there's a balance. And of course, we can try something that's different. But you can see how inefficient it is. So let's try 5 times that. So this is even smaller, I think. This one is even smaller. Okay. So yeah, indeed, it will give you an idea of what kind of step size should be used, okay, for your good approximation. But then it's indeed a search. And now the data here, you can say, in a sense, it's not easy interpretable, right? So then you may want to say, I give everything within one, within one loop. So how can that be done? So this is one option that I sort of thought about. So here I have a step size. Okay. And here you just make a list, but make a list so that the step sizes are decreasing. So here I'm saying I have 0.1 and with a power that's increasing, right? So that's one sequence, but then there's another choice of multiplying the front. So I have 1 times those sequence and I have 5 times those sequence. So what I do here is that it's going to be A times 0.1 to the B. One of the number is the multiplier in the front. One of them is the exponent for firstly, let me do for B in range here. Okay, it's good. So B goes from 1 through 6. That's saying the exponent just gets larger and larger, so the number is getting less and less. But here I'm also choosing A. So earlier I had 5 and 1, right? So I can do 5, 3, 1. So let's just make these choices. So how many step sizes are there? It's going to be 6 times 3 is 18, and it's well, you want to make it in a way that's decreasing. Okay, so let's print the step size. So there are 0.5, 0.3, 0.1, 0.05, 0.3, 0.1, and all the way down. Okay, so this is a way that's a little bit better, like a finer grid than the grid that we originally have. Okay, so originally have two separate grids, but now this is a grid that's one-way decreasing. So that's going to be a little bit easier for you to choose the good step size for the approximation. And then I just form a list. Okay, so so here I'm basically thinking about the way to get another list called the derivative list. So that's gonna be okay for that. So these are the step size for, well, I just do this dx for dx in my step size set, and I print. Mm, Let me think. Do I need, okay, let me also minus error list. Okay. So I minus 240. That will give me a better idea of whether it's accurate or not. And also, it's really up to your choice whether you want to make it a list that's like a long list that's going to the right, or a vertical list that's going downwards. It's 18, 10, 3, 1, 1.3. Yeah, well, it may read ugly, but then let's print it again. Okay, so let's use a loop. But the loop here doesn't have to be a for loop that's written as a for loop. It can be uh, something like this. Print the error, okay, for error in error list. So these are a little bit tricks that you can utilize when you get a little bit more experienced. So I have the list, right? And if you want to make the things a little bit more interpretable, you can do, let me think, print f string. Error at step size, and let me include the step size. So steps, error I, okay, for I in range 0. sentence. I first. So it should be fine. Okay. And now you see issues. Okay, so the numbers just blows up. Wait. This okay. No. This that's the list that we constructed. But this is none type for everything because they are just printed. Okay, so we are printing these values. So these are the errors, and I think this is the best one. That's a little bit more interpretable, okay, when it comes to the outputs. So basically, you see, it's not difficult. It's just a print. It's a is in the what's that term? In one line in the list comprehension. Within the list, I'm only printing the outputs, which is the error at a step size. So that tells me, okay, currently, based on the choices of my step sizes, this one indeed is the smallest. Okay. And you can see indeed for inaccurate approximations that there are all sorts of issues. If the dx is too small and you are raising to a power, then they will give you significant issues. Okay, when the things gets further, when you have the divisions. Remember when you do the second approximation, essentially you have what? You have dx in the denominator, which is not very big, okay? But then in the numerator, if you have tiny little changes due to high power, then that will give you significant errors. And then that will give you this kind of really ugly um, approximations of the third derivative, which is like blowing up. Okay? So that's really large, like 1 billion, 1.8 billion. That's highly unreasonable. That's where your dx is what 10 to the negative 6. Okay. So yeah, so that's the problem of flow point numbers, especially when your approximation is bad. Right? So you can see that kind of like a x plus y for x in set x and y in set y. That trick is utilized right here. Okay. So yeah, so to choose learning rates, so indeed there are ways that you can make the grid a little bit more automated. That's like this. Okay. Okay. Now that's OOP, question 5. So yeah, well, I think the part A for question 5 is kind of systematic. Make sure to um just design the attributes as they specify. Okay, address, style, year, built, number of units, number of floors, right? And then for make sure to get the attributes doors locked, windows locked, windows closed. That's the as the true or false attributes. And then of course you can say locked doors, unlocked doors. There will be methods to change those attributes. Right? So the part A is something relatively fundamental. So it's basically it's tiny little changes that you sort of need to do. Lock doors, unlock doors, close windows, unclose windows. Yeah, one thing I like to mention here is that I would say for checking for this is like a this is a function about checking. So certain attributes are true or false. So they're not really interpretable. So if you just want to say, okay, are all the doors locked in my house? Are all the windows locked in my house? Then you want to return an answer like a sentence. You may want to use the F string so that you're saying, okay, it's true that the windows are all locked, okay? Or if it's false, that the windows are all locked. So that's just like a method that can be written. And you may want to also specify your address so that your conclusion is interpretable. So so that's something really sort of fundamental that you should implement. And later, this if you feel comfortable about this, right? Think about another thing. So there are different kinds of houses that have different kinds of number of floors that they have, right? For let's say for condo, there may be two floors. For a townhouse, could be three, four, right? So now you may think about like an attribute that whether people are in the house on the particular floor or not. And let's say there were lights, there were like water, there are gas, so whether they are on or not, right? And for different floors, there may be different status. So that's something I was thinking about when I was trying to design this kind of my own house. I'm saying, okay, I want to get a quick answer of whether there are lights and water running unattended on the floor where there's nobody there. So then there are the three attributes, right? There are people in on this, like let's say the second floor or not. The lights are on the second floor or not, and the water is running on the second floor or not. And one thing to mention here is that the number of floors there is a variable. Okay, so the number of floors there is a variable. So instead of having the fixed number of attributes, your house may need to define a variable number of attributes up to how many floors you have. So that's something you definitely want to think about. And I'm gonna reveal one way to do it on the screen a little bit later. But basically, it's a loop. Okay, it should be a loop that you for floor one you have said it's people on floor one, people on floor two, people on floor three, and it's up to how many floors you have. So it's a loop. And then similarly for whether the lights are on case floor and whether the water is running on case floor, that's also enclosed in one of the loops. Yeah, so yeah, indeed, there are a lot of things that you can play with for this particular question. Split the beginning part because it's important that when you're designing your class, it's always starting with class and house, and it's always starting with the initial initialization function. Okay, just so make sure. Yeah, I'm just making sure that it's big enough. Okay. So address, style, year built, number of units, number of floors. These are uh, predetermined fixed attributes. And then the doors are locked, the windows locked, windows closed. These are the attributes that you want to firstly implement. And make sure that for the initialization function here, this is a double underscore for the on the left of INIT and also on the right.
was thinking about this.
Oh, that's so good. Yeah, these variable mappings, I was doing this as a demonstration, but currently I do want to switch back to the words because that's a little bit more readable, especially when you are building up your own house and then you want to know which place to put what. You certainly don't want A, B, C, D, and E as the hints. Oh, it's already 2:30. So, well, make sure you play with this part. I th yeah, well, A part is pretty straightforward. B part, you need to think about the ways that you design your own attributes. Next time we're gonna start with a little bit more on the discussion for this question, and then we're gonna jump into section 8. So it will be a little more involved. Okay. But these are indeed really fundamental stuff that you'd like to play with. Right. Yeah, that's pretty much it. If you have questions, just let me know. Otherwise, I'll stop recording and see you guys on Wednesday.